Hi, I'm Melissa, and I wanted to do a video about how to choose U in integration by substitution. And we are assuming that you understand the basic idea of substitution and how to do it. So two common ways to choose U. Either you want U to be the function inside another function, or you want U to be the denominator if you have a fraction that you're trying to integrate. Also, there's a couple of less common choices for U, and we'll look at that in the next video. The key thing when you're doing integration by substitution and choosing U, you know your choice of U is a good one if du is what I call, quote, hanging around, end quote, in the numerator of the integrand. And I'll explain what I mean with some examples. So example 1, this one's going to be choosing U equals the function inside another function. I've got the integral of 5x e to the 3x squared dx, and I'm going to choose U to be 3x squared because it's inside the exponential, so it's the most likely choice for U. And then du is 6x dx. And do you see how the du is what I call hanging around? I don't really care about the 6. What I care about is the x dx. I've got an x dx in my integral, so it's probably going to work. And I always divide the constant over to the other side, so instead of du is 6x dx, I now divide by 6 and have 1/6 du is x dx. And I also like to rewrite the function where I make sure my du is kind of next to each other. So I've rewritten the integral 5 times e to the 3x squared times x dx to make it really clear that that x dx is now 1/6 du. And I make my substitution. I integrate 5 e to the u times 1/6 du, and I end up with integral of e to the u du. We end up with 5/6 e to the u plus c, and then the last thing we always have to do is substitute that u back in. Remember, u is 3x squared, so instead of 5/6 e to the u plus c, I have 5/6 e to the 3x squared plus c. That would be example 1. Example 2, this one doesn't work with substitution. I'm going to choose u as 5x cubed. That's inside the exponential. Just like the last one, it's the most likely best choice for U. And when I find du, I end up with 15x squared dx. But I don't have an x squared in my integrand. I just have an x. So this one's not going to work. And I went ahead and divided by 15 to make it really clear that 1/15 du is x squared dx, and I just don't have the x squared dx in my integrum, so it is not going to work. So we can't solve this one with substitution. Let me do 2 other examples, choosing u equals the denominator, one that does work and one that doesn't. The one that does work is the integral of sine of 2x over cosine of 2x plus 1 dx. I'm going to let u be my denominator, which is cosine 2x plus 1. My du is negative 2 sine 2x dx, and I have that in the numerator, so this one's going to work. I'll go ahead and divide both sides by negative 2, end up with negative 1/2 du is sine of 2x dx, and then I can make my substitution. My integral of sine x 2x over cosine of 2x plus 1 dx is now the integral of negative 1/2 du over u, and this is just going to be a natural log antiderivative. I'll end up with negative 1/2 integral of 1 over u du, which is negative 1/2 natural log of absolute value of u plus c, and resubstitute our u back in. U is cosine of 2x plus 1, so I end up with negative 1/2 natural log of cosine of 2x plus 1 plus c. And the integral that doesn't work with substitution when we have a fraction, in this case we have the integral of x to the 5th over 3x to the 7th plus 2 dx. I'm going to let my u be the denominator, 3x to the 7th plus 2. My du is going to now be 21x to the 6th dx, and we have an x to the 5th in the numerator of the integrand, but we don't want an x to the 5th, we want an x to the 6th in the numerator, so this one's not going to work. Okay, I've got 2 integrals here. I want you to pause the video to try to integrate them by substitution. One will work, one won't. The first one is the integral of 8x cubed over 2x to the 4th plus x dx. And the second one is the integral of 3e to the 5x times the quantity of 2e to the 5x plus 7 to the 8th power dx. I'm going to pause for a second. I want you to do that. Try them, and I'll come back and quickly give you the answers. Okay, so The first one, it's a fraction, so I'm going to let my u be 2x to the fourth plus x. My du is therefore 8x cubed plus 1 dx, and I don't have that in the numerator. If it was 8x cubed plus 1 dx in the numerator, it would work. It's close, but we don't have that plus 1 and we need it, so we can't integrate this with basic substitution. On the second one, the integral of 3e to the 5x times the quantity of 2e to the 5x plus 7 to the 8th power. I'm going to go ahead and let my u be 2e to the 5x plus 7. I'll solve for du. Du is 10e to the 5x dx. Divide both sides by 10. I get 1/10 du e to the 5x dx. And I'm going to move things around a bit, bring the 3 outside. So 3 integral quantity 2e to the 5x plus 7 to the 8th times e to the 5x dx. And the reason I did that was I wanted it to be really clear that e to the 5x dx is that 1/10 du. So now I make my substitution. Instead of 2e to the 5x plus 7 to the 8th, I now have u to the 8th. Instead of e to the 5x dx, I now have 1/10 du, and of course I'm integrating that with a 3 in front still. I'll move that 1/10 out to the front, 3/10, and the integral of u to the 8th is u to the 9th over 9, and don't forget your plus c. Simplifying, 3/10 times 1/9 is 1/30th. Therefore, I have 1/30th u to the 9th plus c, and I resubstitute my u. U is 2e to the 5x plus 7, so I end up with 1/30th quantity 2e to the 5x plus 7 to the 9th power plus c. I hope this helps you understand how to choose u.